Hello everybody, Gustavo Silveira here, creator of The Nerd Musician, and welcome to the DIY MIDI Controller Workshop 3.0. In this free webinar, I'll teach you with real-life examples the precise steps I use to build any MIDI controller I want. At the end of this webinar, you'll be able to build a MIDI controller exactly like this, and also you'll know how to use this as a template to build different types of MIDI controllers, the way you want. And all of that without actually having to write one single line of code or any complicated stuff. And you can start without even having the material needed for building a MIDI controller, because I'll also teach you how to use a simulator so you can simulate your MIDI controller in the browser. Pretty cool, huh? And by the way, this course doesn't require any prior knowledge in electronics or programming. It's for complete beginners, but we will also have lots of really valuable information even for those with experience. So during this webinar, you not only learn how to build a MIDI controller, but we will also learn some basic knowledge in electronics and in the Arduino environment. And by the way, the Arduino will be the brain of our MIDI controller, which is the most important thing we'll be discussing today. And one really important piece of information before we start. At the end of this free webinar, I'll be giving you a super discount on my Nerd Musician Pro course. This is only for those who watch until the end. So yes, I'll be pitching my paid course at the end of this webinar, but you don't need to buy it if you don't want to. With only this free webinar, you'll learn tons, and we will learn how to build a MIDI controller. But in case you want to dive deeper and keep studying with me, you have this opportunity of buying it at a great discount. Fair enough? So let's get started. So which materials do you need for this course? You need one Arduino Leonardo or Pro Micro. The Leonardo has the advantage that you don't need to solder anything, since you can connect the pin headers straight to it and to the breadboard. With the Pro Micro, you have to solder the pin headers so you can connect to a breadboard, but you can also use it for a final project later since it has a smaller form factor, but both have the same chip and will be programmed in the same way. One breadboard, which will allow us to make the connections without having to solder the wires. A couple of tactile buttons, a couple of potentiometers, linear 10K ohms, and jumpers. You can find all the links so you can buy the material below. So what is a MIDI controller? A MIDI controller is an interface that uses the MIDI protocol. So it's any piece of gear that can use MIDI to communicate with another gear. Okay, but what is MIDI then? MIDI stands for Musical Instrument Digital Interface. MIDI is nothing more than a language that was created to allow instruments from different brands to talk with each other. Before MIDI, you couldn't simply connect a Yamaha keyboard to a Moog synth, for example. So in 1983, a group of guys at the NAMM conference decided to create this protocol. In the beginning, it was mainly used by synths, but today it's used in a variety of equipment, such as keyboards, mixers, DAWs, DJ and VJ equipment, and much more. However, sometimes the MIDI controller you need doesn't exist, or maybe is too expensive. And that's when this workshop comes in. And by the way, nice to meet you. My name is Gustavo Silveira, and I am a music technologist. And maybe you already follow me on YouTube and can't wait to build your first MIDI controller. But maybe you just arrived here and didn't even know that building MIDI controller was even possible, and don't know if that's for you. So first, let me tell you the three main reasons why you should start building your MIDI controllers. Number one, you will boost your workflow in the studio. If you use your computer to make music, I'm sure you have your favorite DAWs, plugins, synths, etc. So what if you had at the tip of your fingers dedicated controllers to each of your favorite plugins, in their same configuration, their same layout? This way you can stop wasting your time with generic controllers, having your gear that look exactly like your favorite plugins. It will make your workflow way faster. Number two, you save money. Building a MIDI controller is super cheap. Just to illustrate, for under 40 bucks, you can build a complete launchpad with buttons and a couple knobs. This controller in the market would cost you around $200. Instead of buying one, make 5 different ones, and the way you want. Number three, you can express yourself even more. Since you're already here, I'm sure you love making music or any type of art, right? So have you ever wondered if you could make not only your music, but also the tools you use to make your music? Making them the way you want would allow you to express yourself even more. more. And isn't music and art all about expression? So do it yourself, express yourself. But okay, is building MIDI controllers for you? Let me help you with this question. MIDI controllers have been used for decades now, you know, and are used by many types of professionals such as music producers, studio engineers, VJs, DJs, multimedia artists, and even video and photo editors. So if you are in any of these categories, you will 100% benefit from this course. So who this course is not for? This is a hands-on course. You will need to build your controller. You will need to put some time into learning and building it. If you only want a customized controller but have zero desire to build it, you're better off looking for a company that can do that for you. But let me tell you, I have students that in less than a week had their already first controller done, so keep that in mind. So talking about students, let me show you what some of my students have done. Here I have some videos students sent me or posted in the group. Here you can see a MIDI controller that looks like pretty much exactly like the plugin. Pretty dope. Here a MIDI theremin. Cool idea. Pretty handy DJ controller, even with the scratch wheel. And here another handy dedicated controller to a plugin, to an EQ. And here a keyboard / drum machine / controller. Pretty cool too. And here you can see some pictures. This is the Avocator, a controller that my student Carlos Maranhão did. He's even selling MIDI controllers, doing pretty well. Here's what Holger said. This course is simply great. Everything is explained in a very simple way. The course is structured perfectly and the examples are chosen very good and support learning in an excellent way. Here's a controller, the mixer that Evandro did. This is a big ass controller, even with the PCB. This is an amazing controller that Andrea did. This was even his college master's thesis. A foot controller, a lot of people ask me if they can make MIDI pedal boards, and yes, you can. A nice 3D printed LED launch pad. This is Patrice's controller. He also opened a company and it's just amazing what he does. More amazing controllers now from Andrea. Some cool enclosures of Andrea, and I teach how to make enclosures. Another MIDI pedal board. And here Gustavo says, thanks Gustavo, same name as me, for this awesome course. I hope to keep learning and building new controllers. And here Jenny said, I want to express a huge thank you to Gustavo. I'm so grateful for your classes, Nerd Musician. And she did a hand pan, like a hand drum, but MIDI hand pan, which is also pretty amazing. So let me introduce myself to you. My name is Gustavo Silveira, and I am from Brazil, and I'll be your instructor throughout the Nerd Musician Pro course. Differently from what many of you think, I didn't come from an engineering background. In 2015, I got a bachelor's degree in music composition from the Universidade Federal de Pelotas in Brazil. And back then, I had never soldered a wire in my life. However, in college, I was introduced to a programming environment for multimedia art called Max, which you might know from Max for Live. And that opened a world of possibilities for me. With Max, I could create my own synths, develop software to make melodies and rhythm patterns, etc. But no matter how crazy I went in software, I was still using my generic Akai MPK Mini, which could never give me the same flexibility Max was giving to me. So after I graduated, I was making a lot of electronic music, but I didn't have the right tool for my musical project, the right MIDI controllers. Either the ones I wanted were too expensive, like the Ableton Push, or the ones I could afford didn't fit into what I wanted. So it clicked to me. What if I built one? That's when the journey began. Back then, there wasn't a single source with all the info I needed to learn how to build my MIDI controllers. So it took me months to build my first MIDI controller. It was hard to browse through dozens of sites, tutorials, YouTube channels, etc. But I finally had my first controller made by me, and I freaking loved it. So since I learned how to make one, why not make another one and another one? This way, my controller started to get better, and people started to ask me, can you make one for me? So besides making my own MIDI controllers, I was making some money making controllers for others. That's when I decided to create the Nerd Musician, to help people like me and you to build their controllers, but way faster and easier than it was for me. That any person in a matter of days, not months, could build their MIDI controllers. Since then, my life changed completely, and I even received an opportunity to do a master's degree in music technology at Georgia Southern University in the United States. From there, my work was featured in many blogs and music tech websites like DJ Tech Tools, Gear News, and in the Arduino blog. I presented my work in the biggest maker fairs in the world, like the Bay Area Maker Faire and the World Maker Faire. In 2018, I was a finalist in the Guthmann New Musical Instrument Competition, the most important competition for new musical instruments in the world, with my instrument, the XT Synth. So all of that just to tell you that if I made it, you can make it too. I created this course so anybody can build their MIDI controllers without any prior experience in electronics or coding. This is easier than you think. And here you can see some of the controllers I have built throughout the years. And press here to come back to scale. Okay, so now let's dive into what you've been waiting for, which is how to build your MIDI controller, which I'll teach you in 10 steps in this DIY MIDI controller workshop. Step 1 is sketch your idea. This is the time to be creative. Don't get attached to what you think is possible or not, to your current knowledge in electronics. Just draw what you want for your controller. Do you want a mixer, a launchpad, a controller for your synth? Or are you creating an interactive art installation? Okay, so now that you know what you want, it's time to choose your components. Now it's time to be very specific. Are you going to use buttons? Which kind of buttons? Rotary encoders, faders, LEDs? There are tons of options, but we can categorize them into two main categories: inputs and outputs. In inputs, we can have on-off switches, such as buttons and toggle switches, knobs like rotary potentiometers, slide potentiometers, and rotary encoders, sensors, distance sensors, light sensors, pressure sensors, etc. And we have the outputs. In outputs, we can have LEDs, such as normal LEDs or addressable LEDs, and motors, for example, so it can control motorized faders. The components you choose are totally personal. It will depend if you just want to create a mixer, for example, with only buttons and potentiometers, or if you want to get fancy with LED feedback, motorized faders, or to create crazy art installations. Step 3. Choose the brain or the microcontroller of your MIDI controller. So to control everything inside our MIDI controller, we need a microcontroller. Just like your washing machine has one, your microwaves, and etc. The most popular microcontroller for makers is the Arduino. The Arduino has a great community and tons of examples online, which go from robotics, home automation, MIDI controllers, and much more. The Arduino actually is the name of the company and has several different Arduino models, which will come with different features: speed, number of ins and outs, USB connector or not, Wi-Fi, Bluetooth, etc. The Arduino can transform information from the physical world into the digital world. It has inputs where you can connect buttons, potentiometers, etc., and outputs where you can connect LEDs and motors. And with some coding, you can tell the Arduino what to do with its inputs and outputs. For example, when you press a button, send a MIDI note through the USB and turn on an LED. So let's talk about the difference between digital and analog. As I mentioned, the Arduino has inputs and outputs, and you can have digital and analog inputs and digital and analog outputs. So what is the difference between digital and analog? In the digital inputs, you can connect components that are only on-off, like buttons and toggle switches. Anything that can be represented in one digit, such as 1 or 0, or on or off. And in the analog inputs, you will connect things that have a minimum and a maximum value, such as potentiometers, distance sensors, light sensors, etc. Most Arduinos have analog and digital inputs, so you can connect buttons and potentiometers, for example, but only have digital outputs. This way you can only turn an LED on or off, for example. However, you can simulate analog output using a method called PWM, or pulse width modulation, allowing you to create an illusion that you are changing the brightness of an LED. But don't worry about that right now, because we won't be talking about outputs today, only inputs. Just know that even without a proper analog output, you can simulate one. So if you hear about PWM, that's what is used for. So how it works? So the way the Arduino can tell what's going on in the physical world is through its input pins. The Arduino works with 5 volts, so it needs to be powered through the USB or through a power supply or battery. Then, using the components we'll be using, such as buttons and potentiometers, you can change how this voltage travels through the Arduino pins. Then, the input pins will read this voltage and will convert the signal into digital numbers. This is called ADC, an analog to digital converter, and the Arduino ADC has a 10-bit resolution, which means that it has 1024 numbers to represent this 0 to 5 volts change. So while a button will only give you 2 states, 0 or 1, because it's connected to a digital pin, a potentiometer will give you a reading of 0 to 1023, because it's connected to an analog pin. Then in the Arduino IDE, with a C-based language, we can use these numbers for whatever thing we need and send messages through the USB or manipulate the outputs with voltage to blink LEDs, move motors, etc. Also, the next amazing thing about the Arduino is that it's open source. This means that anybody can look at how it's made and make a version of it and even sell it. So that's why many Chinese companies make Arduino clones, which makes buying them so cheap. You can buy one for less than $5. So I recommend buying at least one original to support the company, but then buy the clones, which have the same quality, but for a fraction of the price. To summarize, the Arduino can transform information from the physical world into digital information. Using some coding in a C-based language, you can tell what to do with its inputs and outputs. Inputs and outputs are divided into digital and analog. In the digital inputs, we can connect buttons and switches, and in the analog, potentiometers and sensors. Outputs are mainly digital, but you can simulate analog with PWM. In the outputs, you can connect mostly LEDs and motors. And while the digital pins will only give you 0 or 1, analog pins will give you a range of 0 to 1023 in its reading. And in case you asked yourself about rotary encoders, they're actually digital. The way they work is completely different from potentiometers. We don't have time to talk about them today, but I do teach how to use encoders inside the complete course. So which Arduino to choose? Choosing an Arduino can be really confusing, since there are several different models. So to choose the right board, you have to keep in mind how many and what kind of components you want. What you need to plug in into your board. Also, you need to know if the board you're getting can be MIDI class compliant, plug and play, because not all Arduinos can. For final projects, my favorite Arduino for MIDI controllers are the Arduino Pro Micro and the TNC-LC. Both are tiny and MIDI class compliant. The TNC-LC is faster with more pins but a little bit pricier, while the Pro Micro has fewer pins, is a little bit slower but fast enough for MIDI controllers, be sure of that, and it's super cheap. And for prototyping, to test things out, my favorites are the Arduino Uno and Leonardo. Both have pin headers which allow you to connect jumper cables. This way, we don't need to solder anything. Perfect to test your circuit before you commit to a final project. Okay, so take a deep breath. I know that's a lot of information, but as promised, I'm delivering tons of information here. You'll be able to watch the replay in your email. It will be available for only a couple of days, so take this time to watch as many times as you want. So, step 4. Design your circuit in a circuit design software. This will give you a full visualization of what goes where. This will be very handy when soldering times come. A really good software to design your circuit is called Fritzing. However, Fritzing now is paid, so we'll be using a different option today, which will be great for what we want. So I will use this amazing tool called Tinkercad. Tinkercad has an Arduino simulator, which allows you to test your project even before you have your materials in hand. Everything in your browser. This way, you can simulate your MIDI controller with me today. So let's take a look at Tinkercad. First, click on the link below called Tinkercad Classroom. In here, you can use this code provided and go to my class. Then join the classroom with your email. And here you can come to Designs and Circuits. And you can come here to New and Circuit to create your design with me from scratch, or come to Classes and click in DIY MIDI Controller. Here in Activities, you can find the project files we'll be using today. You already know the Arduino, so now we need to understand the other components we'll be using today, which are buttons, potentiometers, and the breadboard. So click here on DIY MIDI Controller Workshop class and click here in Button and tinker this. A button is a momentary switch. This means that when you press it, the current will flow through it. And when it isn't pressed, the current will not flow through it. Every momentary button, or SPST, single pole, single throw, will have 2 terminals. The tactile button, although it has 4, it has only 2, and they are 2 extended legs. One terminal will go to a digital input, and the other one will go to ground. So when the button is pressed, the pin can read the difference in the voltage, to high or low. And this high or low, or 5 volts or 0 volts, will tell us if the button is pressed. And here in the code section, we have a simple code that lights up the built-in LED of your Arduino Uno or Leonardo when you press it. So start simulation and try for yourself. So now let's talk about our potentiometers. When you apply current through it, it can decrease the amount of current it is flowing when you move the shaft of the potentiometer. It will change its resistance as you move the shaft. So the more resistance, the less current will flow through it. So depending on the position you have your potentiometer, the input pin, the analog input pin, will read a different voltage from 0 to 5 volts. And each potentiometer will have a resistance measured in ohms, just like a normal resistor. For our MIDI controller, anything between 5 to 50k ohms will work. Just don't mix different values of potentiometers in the same project, because they will give you different reading curves. Also, potentiometers can be linear or logarithmic. We want the linear ones, which are represented by the letter B, while the log is represented by the letter A. So the most standard potentiometer for our use is the B10k ohms potentiometer, which is a linear potentiometer that has a resistance of 10k ohms when it's in its full clockwise position. So the way to use a potentiometer is connecting one of its legs, which is the first leg, to ground, the second leg, or the middle one, also called wiper, to an analog pin, so in this example A0, and the third leg to 5 volts. Note that we'll always use the color black for ground and red for 5 volts, or to VCC also called. So here in our code section, there's a simple example that reads the potentiometer. And here in the serial monitor, you can actually see the value of the potentiometer, just like you do in the Arduino IDE. And note that you get a range from 0 to 1023, just as mentioned before. The next thing we need to learn is how to use the breadboard. The breadboard is the soul of every prototype. It allows us to create connections without having to solder anything. And they come in various sizes. In this picture, it's easier to visualize how it works. We have 2 larger horizontal pieces of conductive material on both sides, and several vertical lines of the same conductive material here. The 2 bigger ones we typically connect to the power, and the other perpendicular ones we use to connect the components of our circuit. So now that we know how to use our components, it's time to put everything together. So now let's go to our step 5, which is prototyping a proof of concept. Even if our controller has 12 buttons and 4 potentiometers, it's always wise to create a prototype with fewer components first, only to see if we know how to use them. If you can use 2, it's easier to scale to 12, for example. So now open the DIY MIDI controller breadboard example, where I have connected 3 buttons and 2 potentiometers. You can start the simulation, and here in code, go to your serial monitor, and see that if I press this one, I have button 0 on, off, then 1 on, off, and these 2 potentiometers will give me the reading from 0 to 127. Now it's 127 because I'm already preparing the code for our MIDI controller, because MIDI ranges from 0 to 127. So feel free to add more buttons, more potentiometers here, and I will teach you how to edit this code to what you need really soon. Okay, so before we do this in real life, let's make sure we understand what's going on here. So let's take a deeper look. From our pin 2, we go to this rail of the breadboard. So notice when I put my mouse here on this column, the whole column gets green. It means that all this part here is connected to the same conductive material. So if I put a jumper or a wire from here to here, and the leg of this button to here, it means that I am connecting this leg to this wire. And remember that I told you that the button has only 2 terminals, this, and actually these 2 legs here are the same terminal, right? This is one extended leg and this is one extended leg. I am using this leg to connect this part to this part. So I can connect this wire here, but also here, since I am connecting this button in the middle of the breadboard. So it's a common practice to put the tactile button in the middle of the breadboard, and that's why it has its extended legs. So you can connect this part of the breadboard with this part here. So okay, one leg of my button is connected to pin 2 and the other leg is connected to this rail here. Now notice that this line here gets green, which is the power rail, or here we're going to use to be the ground rail, because we are connecting one jumper from here to the ground. So everything we connect here now, it will be connected to ground. And we are doing the same thing here, but for the 5 volts. So I am connecting 5 volts to this rail. You even have the colors here in the breadboard, so it's a standard to put ground here and 5 volts or positive here. Okay, so what happens when we press the button? There's actually 2 ways you can connect a button in the Arduino. The other way will require a resistor and more jumpers. So if you see a button connected with a resistor, it's fine too. The way you read this button will change a little bit in the Arduino though, but I prefer to use like this because you only need 2 wires. So what I'm using here is a technique called input pull-up resistor. So instead of using a resistor in my circuit, I am using a built-in resistor that inside the Arduino. So what you really need to know here now is that one terminal of the button will be connected to a digital pin, in this case pin 2, and the other one to ground. So you don't need to put things exactly in the same position as in my breadboard. Let's say I have my button here. I know that pin 2 needs to go to this terminal, so I can only do this, and this terminal here needs to go to ground. So I need to connect here, because this part here, it's already connected to ground. And here in my potentiometer, I have one leg, the first leg, connected to ground, the second leg connected to an analog pin, and the third connected to the 5 volts. Remembering that you can move things around as long as you know which terminal of each component goes where. So now it's time to do it in real life. Okay, so let's do it in real life now, and I'm going to do it a little bit different from the schematic, just to illustrate that you don't need to do exactly like I did there as long as you understand the concepts. So first thing, I'm going to use a different Arduino. I'm going to use the Arduino Pro Micro, which is my favorite for final projects. The only difference between the Pro Micro and the Leonardo is that this one you have to solder the pin headers if you want to snap in the breadboard, and the size of course. But the chip here is exactly the same. So if you use this one or the Leonardo, the programming part will be exactly the same. So you can snap this in the breadboard and use it as any other component in the breadboard. So let's connect this first. Okay, so also we're going to need our tactile buttons, and I'm going to place the 3 in the middle of the breadboard, just like in the schematics. And now our potentiometers. And now we need to use our jumpers. I have tiny jumpers here for the smaller connections and bigger jumper for the longer connections. First thing will be powering the power rails with ground and 5 volts. So this is my ground pin in my Arduino Pro Micro, and I am going to connect to the blue rail. So now all the blue rail is connected to ground. And next I'm going to connect the VCC, which is 5 volts here in the Arduino Pro Micro, to the red rail. A common practice is now connecting the 5 volts of this part to the 5 volts of this part, because remember, these two parts here are different, they are not connected. So I'm going to connect 5 volts to 5 volts and ground to ground. So now I'm going to connect one leg of my button to the ground. I'm gonna do the same with the other buttons and the potentiometers with all the ground legs. So see that I connected the ground of the buttons here and the ground of the potentiometers here. So now I'm going to connect the 5 volts of the potentiometers. Okay, so I have grounds and 5 volts connected. Now it's time to connect to the digital and to the analog pins. So I know that this other leg, I have this one in ground, so this leg here needs to go to pin digital 2, so D2, and in the Pro Micro it's this pin here. Then this one here will go to D3, and this one here to D4. So now let's connect this one, the wiper or the middle pin, to the A0 of the Arduino, and this other potentiometer to pin A1. And our breadboard is ready. See that I didn't do the same exactly configuration I did in my schematics, but the idea, the concept is exactly the same. I have buttons on pin digital 2, 3, 4 and potentiometers in pins A0 and A1. So if you want to add a button or a potentiometer or delete something, how can you do this and edit the code so it can work? Let's do that. So first, let's add one button. We can just drag this button here, and let's delete this potentiometer. So now let's connect this button to pin 5, so we can just drag a wire here. We can add nodes, so we can organize our wire, and another wire here to ground. I'm going to change the color. Okay, so now we have 4 buttons and only 1 potentiometer. So what we need to do now is come into code and find here in line 47 n buttons, which is the total number of buttons. We only need to change this to 4, and here in line 48 is button Arduino pin. Pins of each button connected straight to the Arduino. So here we put the digital pins where our buttons are. So we had 2, 3, and 4. Now we have 5. That's the only thing we need to do for the buttons. So now we scroll a little bit down and find here potentiometers around line 60. And n pots, it's the total number of pots. So you guessed that right, we are gonna put. And here in pot Arduino pins are the pins of each potentiometer connected to the Arduino. The only difference is that now we start with an A of analog. So digital, you don't need to put anything, no letter, only the number. But for the analog pins, you need to put A. So we have A0 and we don't have A1 anymore. So only A0 in the one pin we are using. So now we can start simulation. Now we can come here to serial monitor and see that I got this weird error here. Why? Because I deleted the potentiometer that was in the A0. Let's stop the simulation. So what I can do here is changing the pin A0 to A1 because it's where it actually is connected. So let's start simulation. And okay, so pressing here, button on off, and our potentiometer is fully working. So that's what you do if you want to add or delete components from your circuit. Okay, now you know how to build and edit your circuit in the simulator. You also know how to put everything in the breadboard. So now we need to program this so this can become a MIDI controller. For that we need the Arduino IDE or the Integrated Development Environment. So go to arduino.cc, software, and download the latest version for your OS. Then come to my GitHub page where you will download the code. So come to code and download zip. Then install the Arduino IDE. An Arduino empty sketch looks like this, and here you will write the code to do whatever you want. What you're gonna do is actually opening the file that you just downloaded. So come to code and download the version for your language, so English and Portuguese. Then one really important thing is connecting your Arduino to the USB. You should see some LED blinking. Then we need to install one library. One library is something that helps us to do something in the code without actually having to write a lot of things. And in this case is the MIDI USB library. This will help us to make the Arduino a MIDI USB controller or a USB MIDI controller. So come to Sketch, include library and manage libraries. Here type MIDI USB. And you're gonna find this one, MIDI USB by Arduino version 1.0. Whatever. Mine is already installed, so I can't do anything, but just come here and press install. Next thing is coming to board and choose the board you are using. It can be here the Arduino Leonardo or the Arduino Micro. Let's choose Arduino Micro. You don't have Arduino Pro Micro here because it's manufactured by SparkFun, so you actually have to install the SparkFun AVR boards, but don't worry, you can just come here and choose, for example, Leonardo. Then in Tools, after the board, you need to choose the port. So it's something like USB modem or something like that, or COM4 or COM5 if you are using Windows. Okay, so in line 27, first make sure you have debug. This will allow us to see the message in the serial monitor first, and after we install the USB MIDI library, we need to edit the code to what we need. So remember, it's the same thing as in the simulator. Find here your N buttons and change to the number of buttons we have, which is 3. Then let's edit the pins that we are using, which is 2, 3, and 4. So spaces here don't matter, but the comma does matter. You need to put 2, 3, 4, and inside those brackets, and it has to end with the semicolon. So just don't change anything outside this, okay? So 2, 3, 4. So let's find here now potentiometers. We have 2 potentiometers connected to pins A0, so it's capital A, capital matters, A0 and A1. So now let's press verify. If it's everything correct, we install the library. We should see here done compiling. Next, we need to upload the code to the Arduino. So press upload. Okay, so next we need to see the message in the serial monitor. To do that, come here to serial monitor. This should be 115200, which is the baud rate, but don't worry about that, just choose this number. Now, let's press the button. You see button 0, on, off, and on, off. So everything perfect with the buttons, and now potentiometer 0, it always starts with 0. So you see that sometimes we get some weird artifacts, but now in real life things are not as perfect as in the virtual world, in the simulation. So we are dealing with current and noise, and sometimes the reading will not be perfect, but what you need to get here is a reading from 0 to 127, and the same thing with the other one. So if you got this in the serial monitor and you installed the MIDI library, the only next thing you need to do to make this a real plug-and-play MIDI class compliant MIDI controller is changing this line here. So line 27, or this define here, put here the microcontroller you are using, like in the lines here, followed by 1. I'm gonna show you how you do it. So here is where you choose the board you are using. You can use an Arduino Mega, Nano, which I didn't show here because you also need another software together, which is Hairless MIDI, which is super buggy. So I only taught you how to use Arduino Leonardo and Pro Micro or Micro because they always work. They don't need any extra software. So for that, you're going to copy this, which is the ATmega32U4, which is the microcontroller of this Arduino, and paste here. So you only need to change this to ATmega32U4, all capital, followed by a 1. So now get prepared, because once you press upload, this will become a true MIDI controller. So let's do it. Okay, so now we need to test it. One thing that I like doing, always when I make a MIDI controller, is using MIDI Monitor, which is a software to monitor the MIDI incoming message. So here in sources are the MIDI controllers you have connected. So this is my audio interface, this is my virtual ports, and here you can see Arduino Leonardo, right? If I put micro there, it would show as Arduino Micro. There are ways to change the name of the Arduino to your name, to whatever name you want, and I teach this inside the course. So here, if I press button this first, I see that I have channel 2, note 1, and the velocity 127, which is pressed, and then 0. And then I get note 2, and then note 3. And then in my potentiometers, I have MIDI channel 2, sending MIDI control change 1, and MIDI channel 2 sending control change 2. What if I want to change the control change number or the note number of the buttons. So let's come back to our code. So here come to around line 80, and if you can see the line numbers, come to preferences and choose here, display line numbers. And here you can change the MIDI channel that in the Arduino world here will start with 0 if you want actually 1. So 0 here equals to MIDI channel 1 in real life. And here you can change the lowest MIDI note, which I'll choose 36, which is usually a kick drum. And here the lowest MIDI control change. In order to choose each note for each button or each control change for each potentiometer, I teach that inside the complete course. So let's press upload again. Let's clear the message, and now you can see that we have notes 36, 37 and 38 in MIDI channel 1, and control change 1 and control change 2 in channel 1. Now we know that our MIDI controller is working, we need to test it with real sounds. I'm going to do it with Ableton Live. To use it inside Ableton is like using any other MIDI controller. I'm going to come to MIDI preferences. So here you can see your Arduino Leonardo in and out. We are not using any out because you're not controlling LEDs or motors, for example, and those are things I teach inside the Nerd Musician Pro. But here today we are only using inputs. So let's use track and remote. So to play MIDI notes, we can load a drum kit, for example. So let's load this one. Since I loaded my button here with note 36, we should get the kick drum, which is usually in the note 36, and then I got the next one, and then the snare. So you can see that we are having a plug-and-play MIDI controller here. And to use the potentiometers, we can come here to MIDI. Let's say I want to map my reverb with this one and my delay with this one. So now, or adding some reverb. So it works perfectly as a MIDI controller, so congratulations for our first MIDI controller, my friend. And now we go to our step 7. Design and build the enclosure. Designing and building an enclosure can be a challenging task. It took me many months to achieve a type of design that would be functional, easy to assemble, and also aesthetic. You can truly build an enclosure out of a shoebox if you want to, or do everything manually in wood if you have the skills and tools to do so. Since I don't have the skills and tools to do it straight in wood, I rely on designing my enclosure on a computer, and then I send the design to a company so it can be cut in acrylic, wood, or 3D printed. I like designing my enclosures in Fusion 360, and although Fusion 360 is a 3D software, I export 2D files so I can use them in a laser cutter or in a CNC machine, so I can cut them in wood or acrylic. In Fusion 360, I have a template design that I use for all my designs. I can change its dimensions and all the sides will grow or shrink to the new numbers. It's called a parametric design. Then I have to create the holes for the components I will use. Also, if you don't feel you want to use Fusion 360, I also use Inkscape, which is similar to Illustrator, but it's totally free. I teach both softwares inside the complete course. And here I'll leave you with an enclosure you can use to build a controller with 12 arcade buttons and 4 potentiometers. Also with its schematics and code. Step 8. Mount the components and solder them. Now with all the components and enclosure in hands, grab your circuit design and your soldering equipment and get everything together. For example, now that you know how to build a MIDI controller in the breadboard, you only need to follow the same logic for your final project. I'll build the controller I told you with 12 arcade buttons and 4 potentiometers. So stay with the process of building this controller and I'll be right back. 9. Design your printed circuit board. What if you don't want to spend that much time soldering wires? Or maybe you want to sell your controller, building multiple units. The best solution for you is to design and manufacture your own printed circuit boards, also called PCBs. Although this is not strictly necessary, it will make your project way easier to assemble, more reliable, and with a professional look. For that, I use the software KiCad, which is free and open source. But there are other options like EasyEDA. After my PCB is ready, I send it to a company to manufacture it for me. I usually use Chinese companies like JLC PCB since they're super cheap. Step 10. Expand your controller. So time to breathe a little. We saw so much today. I taught you how to build a MIDI controller using the Arduino platform with buttons and potentiometers. I told you everything about them and gave you tips on how to build enclosures, PCBs, etc. But what if you want to use more components than the number of inputs of the Arduino, for example? If you want to build a mixer with 100 knobs, or if you want to use rotary encoders, motorized faders, LEDs, or other types of sensors, or how to use physical MIDI, Bluetooth, or what if you need complete tutorials on how to design and manufacture enclosures and PCBs. And what if you want to learn how to write your own codes instead of just adapting mine? And what if you have doubts along the way? Who will help you out? And trust me, makers always need help when things don't go as expected. Although I taught you here a lot, there's so much more you can do, and I can't simply put all that information in this 1-hour free workshop. So because of that, I invite you to keep learning with me by joining the Nerd Musician Pro. The Nerd Musician Pro is a complete course bundle where I will teach you that and much more. The Nerd Musician Pro is a 100% online course with instant lifetime access, which you can watch in your own pace. And the course actually consists of 3 complementary courses together. So basically you're getting 3 courses in one. You have the Making Music with Arduino, the Arduino Programming, and the KiCad PCB design. In the Making Music with Arduino, I will teach you how to build MIDI controllers in the easiest and fastest way possible. I will teach you how to use an Arduino, which will be the brain of our MIDI controllers, and how to program this Arduino only changing a couple numbers in my template code, so you can build MIDI controllers with buttons, potentiometers, high resolution or not, rotary encoders, displays. I'll teach you how to increase the number of inputs with multiplexers, so you can use more than 100 components in an Arduino. How to create MIDI banks in your controller. LEDs for MIDI feedback and also VU. Motorized faders. How to make MIDI class compliant devices. How to design and fabricate enclosures, about materials and where to buy them. But okay, let's say you want to make something that's not yet covered by the course. After all, there are infinite possibilities in the maker world, and it's impossible for me to cover them all. So for that, you have the Arduino programming course. There I will teach you actually how to program the Arduino in the Arduino C-based language. And my friend, when you learn how to code, the sky is the limit. And this skill can be easily translated to other programming languages: Java, Python, C++, even land you in high-paying IT jobs. And then we have the KiCad PCB design course, in which I will teach you how to design and manufacture highly professional printed circuit boards, or PCBs. This is perfect if you want to get rid of wires, have more reliable controllers, if you want to make them faster, and if you want to scale your production in case you want to sell your MIDI controllers. This way you can make more money and faster. So the Nerd Musician Pro is a course that covers from A to Z in the process of building MIDI controllers, where you learn how to build your controllers in the easiest and fastest way possible, but we'll also learn how to code if you want to build even crazier things. Also learn how to design and manufacture your highly professional printed circuit boards, so you can go from DIY to professional. So what do you get when you purchase the Nerd Musician Pro? You get the Making Music with Arduino, the Arduino Programming, the KiCad PCB design courses, each one priced at $97, with a total value of $288, plus 2 amazing bonuses. You get total access to my project files, so you can make them for yourself or modify them a little and sell controllers for your friends or audience. Only this is valued at least $99. And you get access to our closed Facebook group, which is invaluable. In this group, there's me and an assistant that is there to help you with your doubts, so you are the priority. And trust me, only this community is worth what you're paying for this course. So I could be easily charging at least $387, but I'm only charging half of that, which is $197. But as promised, I'm giving you an extra discount for you that watched the webinar. So I'm giving you an extra 40% off on top of that $197. So you pay only $117, which is the best deal you can get for this course. But just like this webinar will be only available for the next few days, the discount will too. So you only have a couple of days to decide if you will join with 40% off. And I highly encourage you to do it. Because if you like this 1-hour webinar, imagine what I can teach you in more than 20 hours of content. Plus, you can even start selling your MIDI controllers and recover this money in just one controller you sell. And you can even make it into a business, just like Carlos Maranhão did with his CM MIDI company, which now is a full-time maker. And also, you have a 30-day money-back guarantee, so I'm taking all the risk away from you. You can buy this course, and if it happens you find the course is not for you, I'll give you all your money back. Just send me an email and I'll refund your money. And all of that with instant lifetime access. So if you want to build high-quality MIDI controllers, the way you want, the way you need, in the fastest way possible, so you can stop scrolling through hundreds of YouTube tutorials, if you want to learn how to blend art and technology, and all of that is spending very little money on each controller, the Nerd Musician Pro is for you. So join hundreds of other students and become a Nerd Musician Pro you too. I'll see you inside.